Could there be a million more planets like Earth? I'm Tonya Hall, and joining me is Steve Bryson, researcher at NASA's Ames Research Center. Welcome, Steve.
Thank you. It's very nice to be here.
Tell us about NASA's first exoplanet hunting mission, the Kepler Space Telescope, and give us a quick summary of your involvement with the project.
Well, the Kepler Space Telescope was launched in 2009 to detect planets around other stars at a time when there were not very many such planets detected. And the Kepler Space Telescope has been spectacularly successful. We've detected what are likely to be over 4,000 planets around other stars, of which over 2,300 have been confirmed. And it's been my great fortune to be involved in that mission since before launch. I joined the mission in 2005, which is 4 years before it was launched. And I was very lucky to be kind of in the center of many things. I was involved in the development of software to analyze the data. I was involved in selecting stars and helping to observe the stars. I was involved in operating the telescope in space. And later I was involved in working with the scientists and astronomers to do the analysis of the data. And most recently, I've been involved in looking at the vast amounts of data that we've received to try to eke out the very difficult problem of estimating how many or how common the planets the size of the Earth orbiting stars like the sun at the right distance to have liquid water are.
You're the lead author of a study that looked at Kepler's exoplanet data. The results of the study were just announced. So, what are some of the details of the results you found?
The question we were asking is, what is the fraction of sun-like stars that have planets that are the size of the Earth and then the right distance from their star to possibly have liquid water? The purpose of this question is that we believe that liquid water is required for life as we know it. We only know of one kind of life here on Earth, and that absolutely requires liquid water. And so the question was, how common are planets that could have liquid water? And so we restricted ourselves to stars like the sun, and we were looking for planets the size of the Earth that are the right distance from their star so that they're the right temperature to have liquid water. Now that's the difficult end of Kepler's observations. That's such planets, planets the size of the Earth are difficult to find when they're far enough away from their star to have liquid water. And so this study involved a lot of examining of the data, very careful analysis of the data. And even though we just published this one paper, which announced our final result this month, it is actually the result of years and years and years of effort by a large team. And so we're very, very pleased to have this result finally come out.
How did Kepler identify the presence of a planet orbiting a star dozens or hundreds of light years away? And how do you determine size or orbital distance?
Oh, well, or thousands of light years away, which is what most of the stars that we looked at are. So the way Kepler detected planets is it looked for the very lucky circumstance where, if this is the planet star, where the planet would go between us and the star. And so the planet would block a little bit of the star's light. Now, all stars are so far away that even when you point at the biggest telescopes at them, they're just points of light. And so we're not seeing the planet move in front of the star as like a dot going across the star. We're not seeing that. All we're seeing is that as the planet goes in front of the star gets just a little bit dimmer. And so Kepler really is a telescope designed to very carefully measure the brightness of stars. So what we did was we looked for cases where the star's brightness would dim just a little bit, and then you wait, and then it dims just a little bit again, then you wait, and if we get a repeated dimming, and the way in which the star got dimmer looked just right, we have to be very careful about that, then we say, aha, that's probably because it's a planet going around the star, blocking the light once every orbit of the planet, which of course would be that planet's year. So this required a great deal of precision. It also requires everything to be lined up just right. If the planet is down here, we'll never see it. If the planet's orbiting like this, we'll never see it. And it turns out that for the kinds of planets and stars we were looking at, we would expect this fortunate alignment in only 1 out of 200 cases. So we don't know which stars are going to have the lucky alignment. So what Kepler did was it looked at 150,000 stars all at once. And that was the very brilliant design of Kepler from conceptualized by Bill Barucki, who was the leader of the Kepler project. And so we looked at 150,000 stars at once for 4 years, trying to detect this change, very tiny change in brightness. And we did.
I read that Kepler helped us determine there could be more planets in our galaxy than stars. Is that correct?
That's likely. We're always very careful about such precise answers. It is likely that there are more planets than stars, but that's also not a surprise. I mean, after all, our star, the sun, is just one star, and it's got 8 or 9 planets, depending on who you talk to. Um, and so it would actually be a bit of a surprise if it turned out there was only 1 star per planet on average, because that would mean our solar system was very unusual, and we don't have reason to expect that to be the case. And so Kepler showed that not only are there lots of planets orbiting the stars, but many of the stars we saw, we were able to detect multiple periodic dimmings around the same star. So we would see systems of planets, as many as 7 planets orbiting the same star.
I love it. You say 8 or 9, depending on who you talk to. We still love Pluto, just so you know. The typical planetary system discovered by Kepler is much different than what we find here in our solar system, right? I mean, what did you find along those lines?
Well, so there was quite a surprise, and that that many of the systems that we found of multiple planets around the same star, that those systems are very flat, that all the planets orbiting in the same plane. In our solar system, it's almost flat, but not really. There's just a little bit of tilt that Mercury's orbit is like this, Earth's orbit's like this, Venus's orbit is like that. There's just all this variation. So for example, if there was a Kepler far away and it observed the Earth, well, because of the different tilts of the different orientations of the other planets' orbits, it wouldn't have seen the other planets in our solar system, because they would be going above the sun or below the sun from the point of view where you can see the Earth go in front of the sun. So it was a surprise to discover that that there were many systems where all the planets were in the same plane, and that they were all very close together. It was what we call dynamically packed. They're so close together, there's no room for another planet in there without gravitationally disrupting the whole system. In our solar system, you could imagine places where you could have planets in between. There's a lot of room between the planets in our solar system, so you could have other planets, but that's not the case for many of the systems that Kepler discovered, and that was a surprise.
Kepler was retired in 2018, but
Mhm.
had an interesting history. Can you tell us a little bit about that?
Well, it was launched in 2009. And Kepler was actually specifically designed to have the sensitivity to detect planets like the Earth orbiting stars like the sun with 1-year orbits. In other words, what we call an Earth-Sun analog system. This is a very ambitious goal, and Kepler was designed to attain that goal. So it was launched in 2009, and it worked spectacularly well for a long time. But then we ran into significant trouble with the pointing. So Kepler is measuring the starlight very precisely, which means it has to be rock steady. For astronomers, amateur astronomers out there, you need a really good mount to do really good amateur astrophotography. Well, it's the same with the Kepler Space Telescope, that we needed the pointing to be rock steady, so that when you're pointing at the star doesn't move. Because if the star moves, that introduces noise, which would obscure those tiny little dips we're trying to see. And Kepler worked really beautifully well for 4 years to keeping that pointing. But unfortunately, the method we used for pointing relied on these things called reaction wheels, and they broke. And we ended up in a situation where we only had 2 working reaction wheels. This happened in 2013, after almost 4 full years of observation. And so we only had 2 reaction wheels, which means we could only control pointing in 2 ways, but we have to control pointing in 3 ways. So what do we do? Well, the people who built the spacecraft, the Kepler telescope, the people who built it at Ball Aerospace in Boulder, Colorado, came up with the absolutely stunningly brilliant idea of using the light from the sun to actually balance one of those dimensions of pointing, so that if they realized that if you orient the Kepler spacecraft just right, it would balance, use the sunlight to balance and stop rotation that way, and then you can use your two reaction wheels to control the other directions. Unfortunately, we couldn't do that and keep pointing at the same stars we'd been pointing at for 4 years. And unfortunately, because you had to have it pointed just the right way relative to the sun, we could only keep it up for about 90 days. But I say unfortunately, but all clouds have a silver lining. And um, what we realized is that, oh, well, okay, we can't keep doing what we were doing. We can't look at a bunch of stars for 4 years uninterrupted. We can't do that. But we can look at lots of different places and lots of different stars for 90 days at a time with very high precision. And that became what was called the K2 mission, which in its own way has been revolutionary for astronomy, with a different goals and different purposes, but it has really been a very productive telescope. Unfortunately, and this time I really do mean unfortunately, that balancing act did require the use of onboard fuel, which is a non-renewable resource, and eventually we just ran out of fuel, and that happened in 2018. But from 2013 to 2018, we had a very wonderful telescope and a mission called K2, which did really great work and found its own kinds of exoplanets and did other very important research in astrophysics.
Steve Bryson, researcher at NASA's Ames Research Center. If somebody wants to find out more about the telescope and its missions or and your work, Steve, how can they do that?
The best place to go is www.nasa.gov/Kepler. It's a very nice website with lots of details, including a little story about our most recent paper.
And find more of my interviews right here or on iTunes, Spotify, and YouTube, or at TonyaHall.net. Thanks for watching.